In this video, we will learn how to iterate over a linked list to find the maximum sum of node pairs with static space complexity. Hello, and welcome to the Python implementation of LeetCode problem 2130, maximum twin sum of a linked list. The problem states, in a linked list of size n, where n is even, the ith node, 0 indexed, of the linked list is known as the twin of the n minus 1 minus ith node if 0 is less than I, which is less than n divided by 2 minus 1. For example, if n equals 4, then node 0 is the twin of node 3, and node 1 is the twin of node 2. These are the only nodes with twins for n equals 4. The twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list. For example, example 1, input head is the linked list 5421. Output is 6. Nodes 0 and 3 sum to 6, as do nodes 1 and 2. Example 2. Input head is the linked list 4223. Output is 7. Nodes 0 and 3 sum to 7. Example 3. Input head is the linked list of 1 and some large number. Output is the sum of the two numbers in the list. Node 0 and 1 provide the only sum. What this is really asking is, we have a linked list, we want to iterate over each pair of nodes from the outside in, and look for the pair of nodes that add to the largest value. This is a multi-pointer problem. We can guess that because it deals with a linked list, it finds or alters specific nodes in the list, and it does not find the kth smallest item. If you're serious about acing coding interviews, I've got something that will help. Sign up for the LeetKey newsletter and get weekly LeetCode problems, detailed solutions, and proven strategies delivered straight to your inbox. Now back to the video. You might be inclined to solve this by iterating over each node to create an array, and then using two pointers to iterate over the array from the outside in to find the max sum. But this approach requires two loops and two copies of the data. A more optimal approach is to reverse the second half of the linked list. If we think of the reversed second half of the list as a second list, then we can iterate over both lists simultaneously to find the sum of each pair. And then the pair with the largest sum produces the output. We saw how to find the middle node of a linked list in problem 2095 and how to reverse a linked list in problem 206. Links to these solutions are in the show notes. This solution alters the list in place and doesn't duplicate any data. Let's see how to implement this solution. This solution splits and reverses the second half of a list, then sums each position of the lists. We start by finding the second half of the list, and then reversing it so that we have two lists. We create pointers to reference the position on each list, and initialize the max sum to 0. We loop across both lists until the end of the shorter one. We add the values of the current nodes in both lists, and store the max into max sum. Then move the pointers for the next node in the lists. We continue adding the values at each position of the list until we run out of nodes. We return the max sum. The space complexity for this implementation is static, since we don't copy any list data into arrays or duplicate any lists. That was how to solve LeetCode problem 2130, maximum twin sum of a linked list. Thank you, Christopher, for subscribing. Please like, share, and subscribe for more tutorials. It really helps this channel grow and helps me produce higher quality videos. You can get this video a few days earlier, plus other exclusive content on our Patreon.